This is the second lecture series for research methods, and today we're going to be talking about theory and causality. The goals for this two-part lecture series are, first of all, to start to identify and define key terms of behavioral research. So many of these you'll be familiar with, but you'll be reviewing terms like theory, validity, measurement, and other key terms. We'll talk a little bit about the differences between correlation and causation, and in particular some different ways different concepts may be related in the real world and in theoretical systems. And we'll also be talking about the relationship between a research question and research design using behavioral research language. Ideally, at the end of this lecture series, both Lecture 2 and Lecture 3, you'll be quite adept at using many of these terms to think about behavioral research. This first lecture in the two-part series is going to look at constructs, variables, and measurement. First, just a little thought experiment. Take a second and consider to yourself, which of these 4 options is not like the other? So, actually 5 options: democracy, war, a desk, intelligence, and political interest. If your first thought was that a desk is not at all like the other 4, then you are correct. A desk is quite different. We, in essence, can think about what a concrete exemplar of a desk looks like. You might be sitting at one right now. But concepts like democracy, war, intelligence, and political interest, which are of considerable interest to social science researchers, are far less concrete and more difficult to define and therefore, in essence, to measure and identify. So this will be the fundamental difference between a concept and a construct, at least in the technical vocabulary we're going to use in this class. A concrete or perceptual concept is an abstract idea used to classify specific instances or occurrences of entities. So if one thinks of, say, Plato's allegory of the cave, where there's this pure desk out there, and then we see many different types of desks. Some of them are glass with no drawers underneath. Some of them are children's desks. Some of them are old-fashioned desks with inkwells. Some of them are large and L-shaped. But in our mind, we have this sort of abstract concept called a desk, and then we can sort of measure the extent to which these different desks that we actually see fit into it. A construct is a more difficult and even more abstract notion, because it is used to classify not just in essence, a configuration or combination of observable conditions and concepts. So, for example, a tree, we can see it like a desk, but democracy, it's not always clear. Or in the infamous Supreme Court case, pornography, you know it when you see it. Again, not always something that is clear, and sometimes there's lots of variation in the eye of the beholder. If you look at this image right here, a bird is a great example of a concept. But even of that concept, we have exemplars. So when you think bird, probably one of the first birds that comes to everyone's mind might be a robin, though this is actually a quite cute European robin. Or you might think of something even sort of common like a duck. You're probably not thinking of a flamingo, and unless you happen to live where I live right now, you're probably not thinking of a peregrine falcon. Since they're over my house every day, I think of them quite quickly. So the idea is these are all different types of birds, but some of them come to our mind more quickly. They're more central to the sort of concept of bird, and other types are a little bit more peripheral. And the same will go with anything we try to measure. In essence, if you think about what biologists had to do, they had to develop a rigorous classification system to allow us to know what fits into the bird family and what doesn't. Does the dodo fit? It was flightless. Is flight a necessary attribute of a bird? No. It turns out that you can have flightless birds, and also like the chicken. And so that these are ways that one can distinguish, in essence, and start to classify what belongs in the conceptual category and what doesn't. Intelligence, of course, is not as easy to define or measure, even as something like a bird. So different concepts of intelligence, we might think of it as being something associated with a lot of reading or a lot of mathematical ability. But of course, as the old joke goes, in this famous Far Side cartoon for the Midvale School for the Gifted, often people who are quite practically brilliant, intellectually brilliant are sometimes practically almost incapable of managing everyday things like pulling instead of pushing. Or there was a T-shirt at a gifted camp that said, "I'm preco smart," because the idea was is that people who were quite good at math weren't necessarily good spellers. Um, there's also the sort of types of intelligence that you might get, and this is a shot from Heather's, but maybe updated. I would have used Mean Girls, but perhaps Pretty Little Liars, or one of these shows, or the type of intelligence it takes to play a Game of Thrones, or in The Godfather. One could say Cersei's not so smart, but she somehow or other managed to end up on the Iron Throne nonetheless. So these are the different concepts or ways that we think of intelligence. And in fact, right, there are now 8 different ways we can measure intelligence, precisely because these are contested constructs. And one thing I'll point out is that one of the reasons that social concepts become particularly contested is that being classified as a bird, there's not a lot of moral power to the concept of whether one is a bird or not. Perhaps whether something is classified as a fungus or not, or a planet or not, might be a little bit more, has some moral or value, human value overtones. But intelligence is seen as a good thing by humans, and people want to be intelligent. Therefore, of course, it's going to be far more contested what belongs in the category of intelligent than something like what belongs in the category of bird. So the key concepts that I've been using here are that we have something called a construct. And of course, it could also be concept, but in social science, we're going to be dealing primarily with constructs. And that then we need to think about how we actually go out and measure that concept. And we end up having to operationalize it and measure it in order to turn the construct into a variable. So the operational definition is the thing that sort of forms this pathway between this abstract construct, such as democracy, and the more concrete instantiation that we can actually measure, called the variable. So to be a little bit more precise, so that you have the formal definition here, an operational definition of a construct includes specific classification criteria that allow researchers to measure the construct. So you don't just say intelligence, you might define that more precisely in a way that it actually sets up a measurement criteria. And the thing that we call a variable, or which might also be called a measure or an indicator, is a characteristic of an entity, activity, or situation that varies across observations. So demographic variables like gender or race or years of education, income, right? Of course, we could have other things like score on an IQ test. That might be one way to measure intelligence. Or, ability to read social situations. That might be a form of social intelligence. Note, though, that the way that we're going to, in this class, operationalize things, and in the way that research articles that you read might operationalize things, the definitions used by experts may not always correspond exactly to lay use or everyday use. So you might think you know what a word means, but then when you get into the technical side of things, it turns out that perhaps it's not exactly what you thought. Of course, one of the great examples of this is what is a fruit? Now, many of us might recognize that on this particular image that tomato is not a fruit, but I always like to play this game with my kids. What other things that we sometimes commonly call vegetables are not fruits? Oh, well, it turns out that almost everything falls into that category. So you get cucumbers, you get courgettes or zucchini, eggplant. Why do all of these things fall into the fruit category? Because they are seed-bearing pods, and that is the technical definition. So if you were a botanist classifying what falls into the fruit category, it's seed-bearing pods, and so things like cucumbers and courgettes fall into that category. On the other hand, so then there's no such thing as a vegetable. What they are is all the parts like roots and leaves that wouldn't get classified as a fruit. It's all the other parts of the plants are things we classify as vegetables. It's the same when we think about mammals, right? It's the exceptions we typically think about, say, like a cow, but you're not always thinking, oh yeah, that's right, dolphins are actually mammals, they aren't really fish, but sometimes people think of them as fish. So you have to be careful about this sort of the everyday meaning of a word versus the more technical ways we're going to be defining them in the course. So I'm going to give you two real-world examples here of how much this matters, and it's a hot topic right now politically, which is who is an immigrant. And so a colleague did a study asking people what they think of as who is an immigrant. Now, it turns out there is a technical definition that is used in the UK when people were measuring the number of immigrants who were coming in and out of the UK every year. And it was anyone coming to the UK for more than 12 months. Now, of the people who've met the formal statistical definition, 37% of those were students and 4% were asylum seekers. Now, the reason this matters so much is because the UK government decided to, that got elected, had a policy of reducing net migration. And of course, net migration was being measured by this very definition that I've just explained to you, this anyone coming to the UK for more than 12 months. It was popularly supported. Turns out, however, that everyday people who supported this policy had no idea who actually were an immigrant. Turned out they thought they were people who were coming there for much longer. Only 62% of people thought, only 29% of people thought of students at all, and 62% thought of asylum seekers. People thought overwhelmingly that most of the people coming as immigrants were in fact asylum seekers. It was surprising. So this is a great example of where there is popular support for a policy where the technical definition and the everyday understanding of that word are not at all the same thing. Another great example here is with political ideology. So this has actually become an issue for political scientists, but we tend to think that people are either conservative or they're liberal, for example, right? And so many political science papers are written with that understanding. However, there was a nice paper by Baldessari and Goldberg in the HAS a few years ago that found that it turned out that while it is true that the overall clustering of policy positions for about half of politically active Americans, about I think 35 or 40% of the population overall, did look like a traditional liberal conservative split. About as large of a proportion of the population actually did not look like that. So those people tended to be either economically conservative or socially liberal, or socially conservative and economically liberal. So they actually were what were classified by Baldessari and Goldberg as alternatives. Of course, there was also a small proportion, I want to say 20% of the population, that were agnostic and just had poorly defined attitudes. But again, the idea is that we have to be careful that some of our measures that we use, like right-left, are actually capturing something meaningful that's going on in the real world, alignment and organization of attitudes among actual citizens. Now, measurement, which we've talked about today, this process of turning a variable into a construct, we've looked at some of the pitfalls of it. And part of the question becomes, how important is it to the scientific research process? Now, I think that some of the comments that we had in class earlier this week suggested that it is quite important. And the well-known, or at least you'll probably recognize the last name, Baron Kelvin, of course, the originator of the Kelvin measurement system, said that pretty much if you can't measure it, you have no idea what you're speaking about. If you can express it in numbers, you know something about it. But if you can't measure it, you can't express it in numbers, you basically have as he described, a meager and unsatisfactory kind of knowledge. And you're certainly not at the level of science. Now, that's a pretty extreme statement, but there is some truth to the idea that the better we can get at capturing an idea, the better off we are. But of course now, unlike Lord Kelvin, we aren't always dealing in things that are so easy to classify with numbers. And in fact, the Dilbert cartoon here, I think, accurately captures the alternative argument to Lord Kelvin. When we have Dogbert, who is being the quantifier, and he goes around and he can quantify unquantifiable things, and he decides that somebody is worth $85 and they say, you know what, no one really likes to be quantified. And in the end, that is what we have to be aware of when we do social science, is that sometimes in a quest for objective measurement, we can quantify things that actually are almost impossible, the value of a human life, for example. How do we really quantify that? Now, people have tried. Economists have certainly given it their all. But there are some things that don't fit well into quantification systems. Now, that doesn't mean that they can't be dealt with. We'll be looking at that when we talk a little bit about different types of measurement systems and different levels of measurement. But nonetheless, it's important to keep in mind that as important as measurement is, it always is going to be a lot trickier with the social than it is with physical world.